sit here, and if you start engine A over here as shown, it'll travel around, and when it goes over track contact T2, it'll set the block to green, and one of those engines will pull out whichever way the automatic switching part is set to. Hello, I'm James Ingram. This video is digitized from a 1992 videotape series named V9202. Going back to our construction drawing set, the cover sheet which is shown here, on sheet 2 of these cover sheets is a photograph of the automatic switching block. That's this photograph right here. Then going to that series of drawings, these get rather large. These drawings are, this drawing set is drawn at a scale of 1:4, and most of these drawings will fit on an 11:17 size. However, the switch block, because of its longer length, doesn't quite fit on 11:17. So these, the two sheets for the assembly drawing and the wiring diagram are a little bit longer than 17 inches long. This is the assembly drawing here. This is the assembly drawing for the automatic switching block, which basically here is the outline of the base and the 64-inch length of the thing, and you can see the converging switch. Here is the components that make up the controls for the automatic block part of the unit, and back here is the components that make up the controls for the automatic switching part of the unit. Down here, right here, you may or may not be able to read the dimension, but that's that 6 3/4 inch piece we were talking about a minute ago, the oddball length of piece that was cut to make the lengths of the straight track you add back here to the rear come out to be even length pieces. Up here on the front of the unit is that 3-inch long piece on the front where the track contact T1 is mounted, and that's that 3-inch dimension that I recommend making a 6-inch dimension if your length permits. Proceeding on to sheet 2, another large drawing, we have the wiring diagram, and again all the parts are in the same places. Up here is the components for the automatic block part of the unit. Back here is the components for the automatic switching part of the unit, and all the wires to interconnect those two units to make a completely functional automatic switching block. This is sheet 2. The first sheet we looked at a minute ago, the assembly drawing, was sheet 1. This sheet we're looking at right now is sheet 2. At the moment, there is no schematic sheet 3. Sheet 3 is not in this set. I may get a sheet 3 done at some point if my schedule permits, but right now there's no schematic. Sheet 4, as with the other drawing sets, is notes. This just has some basic explanatory notes on this block, a lot of which we've covered in this film. Then sheet 5 has some more notes, plus the details to make the rheostat mounting bracket. These two holes here, this is the hole. This left edge would be toward the rear of the block, and this right edge would be toward the front of the block. So at the rear, on the rear of this rheostat mounting bracket, are the holes to mount the rheostat R1, which controls the slowdown section. On the this set of holes in the middle is the set of holes to mount the forward rheostat R2, which controls the voltage for the on-off section. Now this hole up in the front here on the unit I've been showing in the the video is empty. What this hole here is for is to mount a Radio Shack indicator light in the situation where you did not install the semaphore arm. If you recall, I said that the 5094 semaphore arm that's on the very front of the block was for cosmetic appearances only. That is, it's an item which I recommend because it adds a lot of interest to the block. But the semaphore arm doesn't perform any electrical function, so you could omit that or add it later. If you should decide to omit it, you would, however, lose the indicator lights that the semaphore arm gives you. When you turn that automatic block part of the circuitry on, you can verify that it's getting AC power because the lights on the semaphore go on. If you take away the semaphore arm, you have no indication that thing is getting AC power. So in that case, I would recommend you use this hole, put a Radio Shack light in here, and I give you the part number in the notes. Put a Radio Shack light in there to be used as an indicator light that block part is getting AC power, so that when you power up the AC to the automatic block part of the circuitry, this light in this hole will go on and give you indication it's getting power. And again, that's only if you omit the semaphore arm. If you use the semaphore arm, as with the unit I built, this can just be an empty hole with nothing in it, as it is on my unit. Sheet 6, this set is the installation drawing. Basically, it shows the automatic switching block here. You can see the outline of the base, I think, and the diverging switch back here, and a 6-inch long piece of straight track in here to make these sliding legs up, and basically you just add as much straight track in these two legs as you need to get these sidings as long as you need to accommodate the length of trains you're operating. Back here behind the switch is the 1015U, which defines the beginning of the slowdown block. In this case, the slowdown block, as this drawing shows, a slowdown block would be from this 1015U, and in the left leg it would be up to this 1015U. In other words, this would be the slowdown block from here up to here in this leg, and the on-off block would be from this 1015U up to the front one. Likewise, in the right leg, the slowdown block would be from this 1015U up through here to this 1015U, and the on-off block in that leg would be from this 1015U here forward to the other 1015U up at the front. Then the smaller scale drawing at the top of the page. Smaller scale drawing gives you sort of a summary of steps to install the thing. Basically put the block in. Step 1 says install the block in the track. Step 2 says install the 1015U isolating track with the gap in the right rail. That's back here where step 2 is done. Step 3 says snap the track contact T2 in the track, and that's shown back here for starting at. That's track contact T2 that sets the block to green when the engine passes over it. Step 4 is connect AC power to the block. That's right here, step 4, 16 volts AC block power. Step 5, verify DC track power is connected, and the DC track power is shown connected in up here. Actually, the DC track power can be connected anywhere from the X's of the block, anywhere around the circle, up to the back of the slowdown block. The key thing is to make sure not to connect the DC track power inside the slowdown blocks or inside the on-off blocks. That'll completely hamper the operation of the unit. But the DC track power can be connected anywhere out here on the main line. And something I don't mention very much, the block essentially interrupts the right rail. So to get power back here on the right rail, it depends on power traveling from up here on the right rail all the way around the loop to get to the back of the block, because the block interrupts the right rail with its gap. So it could be on a permanent layout, or a temporary layout, if you got extra wire and extra time, you could run a jumper wire from the right rail wherever your power is connected back around the block to the rear of it to keep continuity on the right rail. I usually don't do it on displays. I just depend on the right rail delivering the power by going all the way around the loop. However, if you got a bad rail joiner any place in here, you won't get the power back here. So that's just something to keep in mind. In step 6, it says put a magnet on all 3 engines. Step 7 says put engines on track as shown, and they may not show up too well on the camera, but there's a engine B on the left leg right about here, and an engine C on the right leg right about here, and engine A is shown out here operating. So if you put the block in the red state initially, both these engines will sit here, and if you start engine A over here as shown, it'll travel around, and when it goes over track contact T2, it'll set the block to green, and one of those engines will pull out whichever way the automatic switching part is set to, and this engine A will pull in the empty leg and stop, and your automatic switching block at that point should be in operation. Finally, sheet 7 here is again as with the other units, is your parts list and cost estimate. What this basically gives you is your a list of all the LGB and Radio Shack parts to construct this unit, plus the 2 ohmite resistors, and the LGB prices out of the Walters catalog and the Radio Shack prices out of the Radio Shack catalog, using those prices as an estimate. And again, these are just rough numbers because those prices are always changing, but this thing comes up with a subtotal of the parts cost of about $520. If you factor in an estimate of 31 labor hours to build this at $5 an hour, it comes out to $155 labor for a total, your total invested cost in this thing, if you count time and labor, of about $675 or so.